Okay, today we're going to learn about trig and right triangles. So, before we start doing right triangles, I'm just going to review some trig identities. So, right here we have, this is not x, this is sine of alpha. So, sine of alpha equals y over radius. Cosine alpha equals x over radius. Tangent alpha equals y over x, where x does not equal 0. Secant alpha equals 1 over cosine alpha. Cosecant is 1 over sine alpha. Cotangent alpha is the opposite of tangent, which is x over y. And then we know the radius is the square root of x squared plus y squared. And then the Pythagorean theorem is a squared plus b squared equals c squared. And then another way to remember all the sine and cosine is we can use SOHCAHTOA. So where sine of alpha is opposite over hypotenuse, right? Opposite over hypotenuse. Cosine of alpha is adjacent over hypotenuse, right? And tangent is opposite over adjacent. So these will all come in handy when we do the right triangle problems. So let's start it. Okay, so it says here, find the values of the 6 trigonometric functions of the angle alpha in standard position, whose terminal side passes through 4, -2, and then alpha could also be written as alpha. Okay, so we gotta find the 6 trigonometric functions. So first step I would do is draw the graph. So the point 4, 0, 4, -2 is in, so it's right here, 1, 2, 3, 4. You could think of this as a vector. Gotta draw a triangle. So here's alpha, right? This is alpha. This is the 4, 2, so 4 is our x, and -2 is our y, right? So what quadrant are we in? We are in quadrant 4. This is 1, 2, 3, and this is 4. So here's alpha. We said the x value is 4, so here's 4. Our y value is -2, so it's -2 because sine is always negative. Sine is always negative in quadrant 4. Okay, so now that we have our triangle, I gotta finish this. What are we missing? We have an x and a y, but we don't have the rate. This is the hypotenuse, or also called the radius. Radius, they're the same thing, so we gotta find r. How do we find r? We can use the formula r equals x squared, the square root of x squared plus y squared. So in our case, r is the square root. So what's the square of 4? 4 squared is 16. And then -2 squared is plus 4. So that should give you square root of 20. So that simplifies. Here's a 5 and a 4. So our radius is just 2 square root of 5. So over here, it's our radius is 2 root 5. Okay, so we found r our radius. Now we gotta find cosine of alpha, sine of alpha, tangent alpha, cotangent alpha, secant alpha, cosecant alpha, and the other one. So let's find cosine alpha. Remember, cosine alpha is, you could either do the SOHCAHTOA, right? SOHCAHTOA. So it could be, so here's, we want to find cosine, so it's either adjacent over hypotenuse, or you could do, cosine is also, x over radius, right? So that would be x, so we know our x value is 4, and our radius is 2 root 5. Let's rationalize the denominator by multiplying top and bottom by square root of 5. So you're left with 4 square root of 5. Square root of 5 times square root of 5 is 5, and then times it by 2 is just 10. And that simplifies into 2 root 5 over 5. Right? Yeah, sometimes we're gonna just, we can't use like x over radius. Sometimes we have to use SOHCAHTOA, because like sometimes we all use like a different angle. I'll show you when we can only use SOHCAHTOA, but we're gonna do problems where you only can use SOHCAHTOA, not where you can use where cosine is x over radius. Okay, but since we're using alpha, we could just okay. So let's find sine of alpha. Sine of alpha is y over radius, or opposite over hypotenuse. So we know our y is -2, and our radius is 2 root 5. The 2 cancel, so you're left with -1 over root 5. Let's rationalize the denominator, both sides by multiplying the square root of 5. So you're left with negative square root of 5 over 5. That is our sine alpha. Let's find our tangent. Tangent alpha is basically y over x. So our y is -2, and our x is 4. That simplifies into -1 over 2. Let's do cotangent alpha. Basically, cotangent is the reciprocal of tangent, so whatever tangent is, it's just flipped. So it's, what's the reciprocal of -1/2? -2 over 1, or just -2. Okay, let's find secant. Secant is the same thing as 1 over cosine alpha. So it's 1 over, and we know cosine alpha is right here, so it's 2 root 25, this whole thing, so we gotta put all this, so it's 1 over 2 root 5 over 5. I'm gonna do my brackets, so I'm gonna multiply everything by 5. So you're left with 5, and then the 5 cancels over here, so you're left with 5 over 2 root 5. Let's rationalize the denominator by multiplying top and bottom by square root of 5. So you're left with 5 square root of 5. 5 square root of 5 times square root of 5 is 5, times by 2 is 10. That simplifies into square root of 5, right, to 2. Okay, the last one is, I'll put it over here, cosecant alpha, which basically is 1 over sine of alpha. So it's 1 divided by, and we know that sine of alpha is this thing, so we could just put negative root 5 over 5, and then I'm going to do my brackets. I'm going to multiply everything by 5, so you're left with 5 on the top, and then 5 cancels, so it's just negative root 5. Let's rationalize the denominator. Multiply everything by square root of 5, so you're left with negative 5 root 5 over 5, because square root of 5 times square root of 5 is 5. This cancels, so you're left with negative root 5. So that is your cosecant. Okay, so let's do another problem. Okay, so it says solve the right triangle in which A equals 4 and B equals 6. Find the acute angles to the nearest tenth of a degree. So first step, I'm going to draw my triangle. Put it right here on the left. So it's a right triangle. So right always means, you could also draw it the other way like this, but I like it this way better. So we know that A equals 4, so A equals 4, and B equals 6. You can also flip it, like you could do 6 over 4. It doesn't really matter because we're going to use the Pythagorean theorem anyway. So it says find the acute angles to the nearest tenth of the degree. So over here, we don't know what these two angles, right? We'll call this alpha, angle alpha, and we'll call this angle beta. We all know that a right triangle equals 180 degrees, right? So that's a right triangle. Let's find the hypotenuse, or C, right? You use the Pythagorean theorem, right? So it's a squared plus b squared equals c squared. So our a is 4, so it's 4 squared plus b squared, which is 6 squared, equals c squared. So 4 squared is 16 plus 36 equals c squared, and then that's square root of 52. That equals c. And that simplifies to 2 root 13. So right here, our hypotenuse, or our c, equals 2 square root of 13. So we're going to find out these two angles, right? Alpha and beta. So what I would do is I would do cosine let's do cosine of alpha. Cosine of alpha equals x over radius, right, or SOHCAHTOA. Let me write SOHCAHTOA. Cosine So cosine of alpha is six divided by its cosine of alpha is adjacent. Actually, let's not do cosine. Let's do sine of alpha. So sine of alpha is opposite over hypotenuse, right? So this is adjacent, and then here's the opposite. So 6 is our opposite, and our hypotenuse is 2 root 13. Okay, then we simply just do put a 1 under as the denominator of sine alpha, and then we cross multiply, right? So you have 2 root 13 times sine of alpha equals 6. We want to get this alpha by itself, so I will divide everything by 2 root 13. And then you're left with sine of alpha equals 6 divided by 2 root 13. Okay, so I want to get rid of the sine because I want alpha. What we can do is multiply each side by the sine of inverse. This will get rid of the sine and you're left with alpha. So alpha equals sine of inverse of 6 to root 13. Just got to do is put it in the calculator, and then when I put it in the calculator, I get alpha equals 56.3099, and then they said round to the nearest tenth of a degree, so here's tenth, so it's 56.3. So that's what alpha is. Okay, so we found alpha. How do we find beta? Remember how I said that a right triangle equals 180? So we know this is 90. This is 90. Alpha is 56.3 plus beta equals 180. So when you do 90 plus 56, you're left with 146.3 plus beta equals 180. Subtract both sides by 146. And then your beta equals 33.7 degrees. So that's one way of finding beta, or you could have done tangent a beta, right? You would still get the answer, same answer. But I like this way because it's much more simpler. Okay, so let me do another one. The problem says solve the right triangle right triangle in which alpha equals 30 degrees and C equals 6. So we're given an angle and a line segment. So first step, I will draw it. This is 30 degrees. It's also pi over 6 if you want it in radians. Same thing. Here's a 90 because it's a triangle. We'll call this angle beta. They said C, so the C is always the hypotenuse because C is longest. So C equals 6. We will call this, we don't know, we want to find these two line segment, these two values. So we'll call this A or B, or you could call this B or A, it doesn't really matter. So for this one, we can either use SOHCAHTOA or we could do sine of alpha. Alpha is 30, right? So sine of alpha equals y over radius cosine alpha x over radius, and then I think that's all we need to know. Okay, so we got to solve the right triangle. So we could find this value, and this angle. So I know this is beta. Angle beta is 60 degrees, right? Because this is a 30, 60, 90 degree angle. Because if you add 60 plus 30 plus 90, you get 180. So let's do cosine of 30 degrees. Cosine of 30 degrees equals, cosine is adjacent over hypotenuse, or x over radius. We can actually use this rule too. So we know our x value is a. It's also our adjacent value, right? Where is it? Adjacent. And then over hypotenuse or over radius. This is where I'm getting the radius, and this is where I get the hypotenuse. So we said our hypotenuse is 6, because that was given. And then put a 1 under here. And then we cross multiply, right? Multiply this, cross multiply like that. So you're left with 6 cosine of 30 degrees equals A. So 6, and we know what cosine 30 degrees from our right triangle, for our unit circle. So cosine of 30 is root 3 over 2 equals A. That simplifies into 6 divided by 2 is 3. So it's 3 over times by root 3 equals A. Okay, so we know what A value is. How do we find B? You can either do this, you could do the Pythagorean theorem, right? Or you could do sine of 30 degrees, right? So you want to do that, you want to do sine of 30. sine of 30 equals y over radius. Here's your x, so we don't know what our y is, our b value, which we don't know, over radius, which is 6. So sine of 30 is 1/2. Oh wait, put a 1 under. Then we cross multiply, so you're left with 6 sine of 30 equals b. So 6 times sine of 30 is 1/2 equals b, and then 6 over 2 is 3. So 3 equals b, or that's one way, or you could have just simply done the Pythagorean theorem, right? So we could have done a squared plus b squared equals c squared. So we know a is 3 times root 3 square plus, we don't know what b squared, and we know c squared is 6, so it's 6 squared. So 3 to the root 3, 3 times root 3 squared is, so that's 3 squared is 9, and then square root of 3 times the square root of 3 is 3 times plus b squared, and then 6 squared is 36. 9 times 3 is 27 plus b squared equals 36. Subtract 27. So you're left with b squared equals 26 minus 36 minus 27 is 9. Take the square root of both sides. So b is just 3. So there's 2 ways you could have done it. Okay. Let's do another problem. Okay, so the problem says, assume that this is, by the way, assume that this is not an x, it should be alpha. Because I couldn't find alpha on the keyboard, so that's why I use x. So assume that alpha is an angle in a standard position whose terminal side contains the given point. Find the exact values of sine alpha, cosine alpha, tangent alpha, cosecant alpha, secant alpha, cotangent alpha. Okay, so we are given the point square root of 6 and negative 2. This is what we are given. So this is our x and this is our y. First step I would do is draw it. So what quadrant would you think we're going to be in? Where sine is negative and cosine is positive, so we're going to be in quadrant 4, right? Draw the triangle. Let me draw it better. Okay, so this is our x value, here's our y value. So this is our x value and this is our y value. So our x is square root of 6 and our y value is negative 2 because it's in quadrant 4. And then let's find the hypotenuse. Simple, it's just so c, it's just square root of x squared plus y squared. So c equals square root of 6 is 6, and then the square of negative 2 is positive 4. So c equals 6, 7, 8, square root of 8. That simplifies to 2 root 2. So right here, our c is or our hypotenuse is 2 root 2. So we'll call this angle alpha. It's a right triangle. So cosine alpha, so let's find our cosine alpha. Cosine alpha, it's x over radius, so here's our x value, it's positive, so it's square root of 6. Our radius is 2 root 2. I'm going to rationalize the denominator by multiplying everything by top and bottom by square root of 2. So square root of 6 times square root of 2 is square root of 12. This is just left with 2, and then times it by an extra 2, which is positive 4. That simplifies. Square root of 12 is like 4 and 3, so it's 2 root 2 over 4. This simplifies into square root of 2 over 2. Wait, I didn't do this right. Okay, so square root of 12 is the same thing, so here's 12, 4 and 3, so it's the good one always, so it's 2 root 3 over 4. That simplifies by, now it's just square root of 3 over 2. So that's cosine of alpha. Let's do sine of alpha. Sine of alpha is y over radius, so we know the y value is negative 2. And then our radius is 2 root 2. Sorry, this is not, the y value should be negative root 2 over 2. That was my mistake. Still the c value, if it was still negative root 2 over 2, the c value is still 2 root 2. Okay, so the square root 2 cancels, so you're left with negative 1 over 2. Okay, sine alpha, tangent, let's find tangent alpha. Tangent alpha is basically y over x. So our y value is negative root 2, and our x value is square root of 6. Let's rationalize the denominator by multiplying everything by square root of, top and bottom by square root of 6. So this is left with negative square root of 12 over, this is just 6, and then 12 is same thing as negative 2 root 3 over 6, and that simplifies as negative root 3. 6 divided by 2 is 3. So you're left with negative root 3 over 3. Good. Let's do cosecant. Cosecant alpha is the same thing as 1 over sine of alpha. So it's 1 over, and we know that sine is negative 1/2. So it's 1 divided by negative 1/2. I'm going to do my brackets. Multiply everything by 2, so you're left with 2 over 1, and then don't forget the negative, so you're just left with negative 2. Okay, good. Let's see, cosecant, is that 6, all 6? 1, 2, 3, 4, no, that's 4. Okay, let's do secant and cotangent. So secant of alpha is 1 over cosine of alpha. So that's 1 over, we know that cosine of alpha is square root of 3 over 2. Do the brackets, multiply everything by 2, so you're left with 1 times 2 is 2. The 2 cancels in the bottom, so you're left with square root of 3. Multiply everything by square root of 3. So you're left with 2 root 3 over 3. So that's your secant. Now, cotangent is really simple. It's whatever the tangent is, it's just flipped. So here, cotangent of alpha. So we said that tangent is negative root 3 over 3, so we just have to flip it. So it's 3 square root of 3. And then when you rationalize the denominator, so cotangent of alpha is 3 root 3 over 3. Don't forget the negative. So you're left with negative root 3. Okay, good. Now we found all 6. Let's do another one. So now we got to find the exact value of sine alpha, cosine alpha, tangent alpha, then sine of beta, cosine of beta, and tangent beta for the given right triangle. So, by the way, this is not an x, this is an alpha, and then this is not a b, this is beta. So here we are given this triangle. So we are given 9 as one value, and then our hypotenuse 15. We don't know any of these angles, so we'll call this angle beta. And then I don't know what this angle, so I'll call this angle alpha. So what we got to find is the value of angle alpha, angle beta, and then we need to find our A value, or it could be our B value. It doesn't really matter. So let's find A value. That's real simple. You just do the Pythagorean theorem. So it's a squared plus b squared, which is our 9, so it's 81, equals, and then our c squared is always hypotenuse, which is 15 squared is 225. So then I just subtract 81 both sides. So our a squared is 144. And then take the square root. So a equals 12. So right here is 12. Okay, so let's find sine alpha. For this problem, I will use SOHCAHTOA. It's really important that you label this alpha and beta because it can get confusing. So know where alpha is and know where beta is on the triangle. So sine of alpha is here sine. So we got to find the opposite over hypotenuse. So the opposite is not 9. The opposite side is not 9. It's 12 over hypotenuse, and we know that's 15. That simplifies as to 4/5. Let's do cosine of alpha. cosine of alpha right here is, here's alpha. So we got to do the adjacent over hypotenuse. So our adjacent side is 9, and our hypotenuse is 15. That simplifies this to 3/5. Let's do tangent of alpha. Tangent is base of alpha, right here is alpha. So tangent is opposite, which is right, the opposite side is 12. And then here's alpha, and then adjacent is 9. So yeah, you have to really make sure, you need to know where you're starting at. So 12 over 9 simplifies that in 4 over 3. Now let's do sine of beta. So I need to know, I'm right here at beta, I'm not here anymore, I'm over here in beta. So sine is, we need to know the opposite side. So this is adjacent, so the opposite is 9 over hypotenuse, which is 15. That simplifies to 3/5. Let's do cosine of beta. Here's beta. Cosine is adjacent, so our adjacent side is 12 over hypotenuse, which is 15. That simplifies to 4/5. And then tangent beta. Here's beta. Tangent is opposite. Here, so the opposite side is 9. And adjacent is 12. And that simplifies to 3/4. Okay, we've done that one. Let's do another one. Okay, so it says, assume that alpha is an angle in standard position whose terminal side contains the given point, and that alpha is less than 0, alpha is between 0 and pi halves. Find the radian measure of alpha to the nearest tenth of a radian. So they were given this point, square root of 5, comma 1. So first I will, so they're saying that alpha is greater than 0, and then alpha is less than pi halves. So basically you're only in quadrant 1, so here let me draw it. Here's 0, pi halves, so we can only be in quadrant 1. So let's draw the triangle. We'll call this angle alpha, 90. We don't know this angle, so we'll call this beta. Okay, so the square root of 5 is our x, and the 1 is our y value, so square root of 5 and 1. So what can I do? Let's find the radius, or the hypotenuse. So the radius is square root of x squared plus y squared. So we know our x value is square root of 5, and then square that is 5. And then square root of 1 is just 1, so radius equals square root of 6. And that simplifies, that's the most simplified it can be. Square root of 6. So I gotta find this angle, right? This is the goal I want to find. I want to find this angle. So I will do sine of alpha equals, so we know that sine of alpha is y over radius, or you could do the SOHCAHTOA. In this case, we could actually use y over radius. So here's our x, here's our y, so it's so sine of alpha equals 1, and then our radius is square root of 6. Put a 1 under here, and then we cross multiply. So you're left with square root of 6 times sine of alpha equals 1. Divide everything by square root of 6. So you're left with sine of alpha equals 1 square root of 6. Let's rationalize the denominator. So sine of alpha is square root of 6 over 6, square root of 6 over 6. And then I want to get this alpha by itself, so I'm going to multiply everything by sine inverse. So our alpha is sine of inverse of square root of 6 over 6. Okay, when you put it in the calculator, you're going to get a degree, right? You're going to get a degree. So, but the answer they want the answers in the nearest tenth of a radian. So we got to convert degree to radians. So whatever the degree is, you times it by pi. So whatever the degree is, so when you put this in the calculator, you're going to get a degree, and then you times it by pi, not 180. There's actually, when you put it in the calculator, there's a button that says pi, and then you divide that by 180. And then you should get about 0.4205. And then they want it rounded to the nearest tenth, so it's just 0.4. So this alpha is 0.4 in radians. And it's about 24.1 degrees in degrees. Let's do okay, so let's say we are given two things. Alpha equals 16 degrees and C equals 20. So first I'm going to draw my triangle. We know it's going to be in quadrant 1. 16 degrees is right here. It's really small. 16 degrees, 90. We don't know this angle, so we'll call this beta. So, and we know our C is 20, so our hypotenuse is 20. So we gotta find beta and then A and B. Or you could call this X or Y, it doesn't really matter. We could find beta really simple. Just you can add 90 plus 16 plus beta equals 180, and then you could solve that, and then here 16 plus beta plus 90 equals 180, and then beta should equal 74 degrees. So we know beta is 70, so this is 74. Oops. 74, so now let's find A and B. So I will do sine of sine of 16 degrees equals y over radius. So here, that's our x, and here's our y. So it's our y is b, and our radius is 20. Put a 1 under, cross multiply, you get 20 sine of 16 degrees equals b. And that you should get, when you do the work, you should get 5.5, 112 equals b. I'll just round it to 5.5. Now let's find a. You can find a by doing the Pythagorean theorem. So we know a squared plus b squared equals c squared. So if we don't know what a squared is, and we know what b is, so it's 5.5 squared is about 30.25. And then we know our c is 20, and 20 squared is 400. Subtract 30, both sides, 30.25. So you're left with a squared equals square root 369.75. So a, when you do the work, it's about 19.22. So I'll just round it to 19.2. So we know our a value, and we know our b value, and we know our beta. Okay. The last and final problem is a word problem. So the question says, the angle of elevation of the top of a water tower from point A on the ground is 19.9 degrees. From point B, 50 feet closer to the tower, the angle of the elevation is 21.8 degrees. What is the height of the tower? So we gotta find this y value. So let's find x. Let's find this value. So x is I'll put it right here. X is tangent of 21.8 degrees equals y over x. When you put the 1 under, and then when you cross multiply, you get x times tangent 21.8 degrees equals y. And then when you divide everything by tangent of 21.8, tangent of 21.8, you're left with x equals y over tangent of 21.8. Okay, so since the distance to the base of the tower from point A is x plus 50, right? So it's x, that's how I got x. It's this whole distance, which is x plus 50. We can say tangent 19.9 degrees equals y over x plus 50. Cross multiply, you get x plus 50 times tangent of 19.9 equals y. Okay, so to find the value of y, we must write an equation that involves only y. Since x equals y divided by tangent 21.8, we can substitute y divided by tangent 21.8 for the x in the last equation. So over here, we're going to substitute it. So y equals y divided by, y times, y divided by tangent of 21.8 plus 50 times it by tangent of 19.9 degrees. Good. Okay, so now I'm going to do the distributed part. I'm going to distribute this. When you distribute tangent of 19.9, you get y equals y times tangent 19.9 degrees over tangent 21.8 degrees plus 50 of tangent 19.9 degrees. So I just did the distributed property, and then what I'm going to do is I will see where there's a y. I want to get all the y's on one side, so what I'm going to do is subtract this whole thing. So you're left with y minus y tangent of 19.9 degrees over tangent 21.8 degrees equals 50 tangent of 19.9 degrees. So now on the left side, they're all y, so I want to factor out a y. So when I factor out a y, I get, I'll put it right here, y 1 minus tangent of 19.9 degrees over tangent of 21. So, and that should equal to 50 tangent of 19.9 degrees. So what I want to solve for y, so I have to divide everything by this whole thing, right? When you do that, you get y equals 50 tangent 19.9 degrees over 1 minus tangent of 19.9 degrees over tangent of 21.8 degrees, and then when you do all the work, when you do all the calculated, y should be about approximately 191 feet. And that's it for today.